Hey guys, today we are talking about conditional probability and the we use two-way tables to find probability of certain events, and they're a great way to set up for that conditional probability. So our two-way table is talking about what is the probability that a randomly selected person in the class uses Snapchat, uses TikTok, uses both, or neither. So we have 17 people have both Snapchat and TikTok. See it right there. And then you have 3 people that have Snapchat but no TikTok. You've got 1 person that falls under TikTok but no Snapchat. And 2 people that have no TikTok and no Snapchat. So when we find our totals, you're looking here, if you're looking across the Snapchat, this whole row here adds up your Snapchat and it gives you a total of 20. Then you look across the row of no Snapchat, there's 3. Then you look down the column of TikTok and you've got 18. And then down the column of no TikTok and you have 5. And this equals 23 people altogether. So then when you are finding those individual probabilities, so for the probability of Snapchat, you want to find the total Snapchat, 20, over the total number of participants, 23. Then for no Snapchat, you find that total for no Snapchat, 3 over your total number of participants, 23. Then TikTok, of course, would be 18 over 23. No TikTok would be 5 over 23. Next, we come into our probability of these kind of groups. So the first one, we've got probability of Snapchat and TikTok. So you want to find Snapchat and TikTok together right there, 17 over 23. Then you've got Snapchat and no TikTok would fall right there, 3 over 23. Then we've got no Snapchat and TikTok, 1 over 23. And no Snapchat and no TikTok, 2 over 23. So we are going to use these in a second for our conditional probabilities. So conditional probability is the probability of an event occurring given that another event has already occurred. Probability of A given B. And you've got that formula right there. You write that probability of A over B. And it is the probability of A and B happening divided by the probability of B. So an example, find the conditional probability that a randomly selected student likes TikTok given that they like Snapchat. So we're looking for TikTok given Snapchat. So our TikTok is A and our Snapchat is B. So we want to do probability of TikTok and Snapchat divided by the probability of Snapchat. So if we look at those probabilities from above, we will see that the probability of TikTok and Snapchat was 17 over 23, while the probability of Snapchat was 20 over 23. This reduces down to 17 over 20, or 0.8585%. And then looking at example 3, find the conditional probability that a randomly selected student does not like Snapchat given they like TikTok. So no Snapchat given TikTok. So this time no Snapchat is A, TikTok is B. We want the probability of no Snapchat and TikTok divided by the probability of TikTok. Looking at our probabilities above, that's 1 over 23 and 18 over 23, which reduces down to 1 over 18. And there's our conditional probability. Here is a check for understanding. I want you guys to go ahead and try these problems, pause the video, and come back for the answers. Okay, hopefully you got a chance to try those. Here are the answers if you want to pause and check yourself. Next, we're going to talk about the multiplication rule. The multiplication rule is the probability that event A and event B will occur in sequence. So we'll know we're talking about the multiplication rule when we see that and. So the formula is the probability of A and B is the probability of A times the probability of B. So let's practice that multiplication rule with example 6. Find the probability of flipping a coin and getting heads up, and then rolling a 6-sided die and getting a number less than 2. So we're looking for the probability of heads and the probability of a number less than 2. So it's probability of heads times the probability of a number less than 2. The probability of getting heads on a coin is 1 out of 2. And the probability of getting a number less than 2 is just 1 out of 6 because that's just the number 1. So your probability would be 1 over 12. B, find the probability of choosing a heart from a standard deck of cards and then choosing an ace from the same deck of cards. Assume the first card was returned to the deck. So we're looking for the probability of a heart and an ace. So first is probability of heart times the probability of an ace. So for a standard deck of cards, there's 52 cards. And since there's 4 suits, there's 13 of each suit, so there's 13 hearts. Then aces, there's 4 aces in a deck, and there's still 52 since we returned that first card. So we get 52 over 2,704. C, find the probability of choosing a heart from a standard deck of cards and then choosing an ace from the same deck of cards. Assume the first card was not returned. So here we have the probability of heart, an ace still. So your probability of heart, it's a really bad heart. There we go. And probability of ace. So we multiply. So our heart is still 13 over 52. But this time our ace is 4 out of the 51 remaining cards. So we have 52 over 2,652. The last thing we're going to see in this lesson is this ace or king game. You're given 5 cards, 2 of them are aces, and 3 of them are kings. So you have these 5 cards. And you draw 1 card, and you keep it. And you draw a second card, so you've got 2 cards from those 5. And you win if both are the same card, so if both are aces or both are kings. So I've played the game out here, and you can see that I won the game 3 times out of the 10 times I played, so I won about 30% of the time. So let's look at a tree diagram for this game. So remember, there are 2 aces and 3 kings. So the probability that your first card is an ace is 2 out of 5. And the probability that your first card is a king is 3 out of 5. Then once we go to draw that second card, when your first card's an ace, you're left over with 4 cards, only one of them being an ace. So the probability that the second card is an ace is 1 out of 4. And once you have that ace taken away, you've still got 4 cards left. 3 of them are kings, so the probability that second card is a king is 3 out of 4. Then if you play where you got the king first, then you have 4 cards left over, 2 of them being an ace and 2 of them being a king. So the probability that the second card is an ace is 2 out of 4. And the probability of the second card a king is also 2 out of 4. So to find the probability that first card is an ace and second card is an ace, we multiply those probabilities. So 2/5 times 1/4 would give us 2/20 or 1/10, 10%. Then we have our first card's an ace and second card's a king. 2/5 times 3/4 would give us 6 out of 20 or 3 out of 10, 30%. Then here we have 3/5 times 2/4, which would be 6 out of 20 or 3 out of 10, 30%. And it's the same multiplication problem down here. 3 out of 10, 30%. And looking at this, we can see which ones would be our winners. This first is an ace and second is an ace, those match. So this would be a winning combination. Same thing down here at the bottom. First is a king and second's a king. That is a winning combination. So only these two paths get you to be a winner. So in example 9, find the theoretical probability of winning the game. It would be your probability of winning with aces plus our probability of winning with kings. So we would do that 10% plus that 30% would give us 40% probability of winning the game. And then the next one's a conditional probability. What is the probability that the first card is a king given that the person won? So first king given that they won. So that conditional probability would probability first king and won divided by the probability that they won. So the probability that your first card's a king and you won would be that probability that your first is a king and your second is a king, which from above we know that was 30%. And then the probability that we won, also we figured out above 40%, which that would divide down to 0.75 or 75% chance that the first card was a king given that the person won.